we want to look at how to change from moles to atoms, or moles to molecules, moles to particles, moles to protons, and vice versa. So in case you are given any question that you have something in moles and they want you to find the number of atoms, or you have the number of atoms and you have to find the number of moles. Now, one thing I want to say is that 1 mole is equal to 6.02 times 10 raised to 23, and this number is called the Avogadro's constant. It can also be called Avogadro's number, and so 1 mole is 6.02 times 10 raised to 23. So a mole can be this number, Avogadro's number of atoms, of molecules, of particles, or protons, or whatever. Particles, what is a particle? A particle is either an atom, a molecule, anything. We are made up of particles. So that is, in some books you are going to see atoms, some books molecules, particles. Okay, now you can look at 1 mole as 1 dozen. You know that a dozen is equal to 12. It's the same way a mole is equal to this number, or a pair is equal to 2. So if I tell you that I have 2 pairs of shoes, you understand it as I have 4 shoes. Or if I have a pair of shoes, you understand it as 2. If I talk about a dozen of eggs, you understand it as 12 eggs. If I talk about 1 mole, you should understand it as 0.02 times 10 raised to 23. So if I say 1 mole of hydrogen atom contains 6.02 times 10 raised to 23 hydrogen atoms. So a mole contains this amount of atoms. It could be particles, it can be molecules. Yes. Now let's look here. So the whole thing is 1 mole is equal to 6.02 times 10 raised to 23 atoms. This expression here can be expressed in this fashion. So you can say 1 mole, there is 1 mole in 6.02 times 10 raised to 23 atoms. You can also express it in this ratio, 6.02 times, you can express this in also this ratio, 6.02 times 10 raised to 23 atoms are in 1 mole. So these 2 things, I hope it's okay now. Now, depending on which question you are given, you can use convention factors and choose one of these to solve your problem. Let's look at a problem I have here. My problem is how many moles is 8.1 times 10 raised to 23 H2O atoms, or water atoms. So I know that I have the number of atoms. What I want is the moles. So which of these ratios or formulas do you think I should choose so that I can get moles? I will think I will choose this formula, because if I choose this formula and I multiply this formula by the atoms, the atoms will cancel out and I'll get the number of moles. That is what the question is asking for. So let's go on and do that. Sorry, so I put my points here. This is times, and then I write 8.1 times 10 raised to 25 atoms. Now the atoms cancel each other, and now I have to resolve this. I have to put 8.1 divided by 6.02. If you know the 10 raised to 25 and the 10 raised to 23, that I can easily do, because if 10 raised to 25 is divided by 10 raised to 23, so we just subtract the exponents. So we have 10 raised to 2 here. Now with the other one, the 8.1, if you plug it into the calculator, I've approximated what I had. I had 1.35. I approximated it to 3 significant figures, because I have here, this is in 3 significant figures. Oh, and this, actually I can approximate it to 2 significant figures, because if you look here, I have 2 significant figures here, and normally we choose the smallest significant figure to express our solution. So we can also put this as, maybe we put, it's better to put it at 1.4 moles. So this is the solution. Now let's look at another question. We clean here a bit. The next question says, how many atoms is 6 H2O moles, or 6 water moles? So now we are given the moles, but we are looking for the atoms. So if we look here, we have to choose one of these ratios. Applying conversion factors, we have to choose one of these ratios. And if I think of it, since we have been given the moles, I want moles to cancel, so I will go for this formula, because if I go for this formula, I will get my atoms. So in the same light, I have moles here. Now I put my 6 here. I put times 6 moles. And the moles cancel out. We have more. Now we plug into our calculator 6 times 6.02 times 6. What did I get? I get 36.1, because I've approximated it, atoms. I use 3 significant figures because here this is 3 significant figures, and 6 is considered, if you are given any whole number, a whole number has infinite number of significant figures. So definitely this is smaller, so I express it in 3 significant figures. Thank you for watching. Please don't forget to subscribe to my channel for more videos. Thank you. Bye.